Good morning, dear students. Welcome to the study of P block elements. In the previous class, we studied group number 15, that's a nitrogen family. Today, let me begin with the next group, group number 16 elements. Group number 16 elements are also called chalcogens. The elements present in group number 16 are oxygen, sulfur, selenium, tellurium, polonium, and livermorium. This group number 16, is also known as oxygen family. The first member of the group is oxygen. It's called oxygen family, or even it's called chalcogen. These elements are called chalcogens. The meaning of chalcogens is that these elements uh, are ore forming elements. The meaning of chalcogen is what? Ore forming elements. Most of the ores and minerals, they contain oxygen and in particular sulfur. So these elements, in particular oxygen and sulfur, they form the composition of ores in the form of oxides, in the form of sulfates, sulfides, silicates, carbonates. Okay, these all contains what? Oxygen, and some minerals or ores contain even sulfur also. So hence the name ore forming elements. Okay, so ore forming elements andre chalcogens. Okay, fine. So in this group, we will be studying periodic properties, physical properties, chemical properties, uses and occurrence of oxygen family. Later, we will discuss some important compounds of oxygen and sulfur. Okay, let me begin with the first concept. Let us look at the occurrence of each of group number 16 elements. ಯಾವ ಫಾರ್ಮಲ್ ಸಿಗ್ತವೆ, ಸಲ್ಫರ್ ಯಾವ ಫಾರ್ಮಲ್ ಇದೆ, ಆಕ್ಸಿಜನ್ ಯಾವ ಫಾರ್ಮಲ್ ಇದೆ ಅಂತ ಕ್ವಿಕ್ ಆಗಿ ಗ್ಲಾನ್ಸ್ ಮಾಡೋಣ. ಎಸ್, ಓಕೆ. ಫಸ್ಟ್ ಮೆಂಬರ್ ಆಕ್ಸಿಜನ್. It's a most abundant element on the earth crust. Look at the graph. Look at the graph. Oxygen forms about 46.6% by mass of the earth crust. That means if you consider the mass of the earth crust as 100%, out of that 100%, nearly 50%, 46.6 andre almost near to 50%, almost half of the mass of the earth crust composed of what? Oxygen. Oxygen means not only in the form of O2, in the form of oxides, in the form of sulfate. Sulfate also contain oxygen. Carbonate also contain oxygen. Silicates also contain what? Oxygen. So these rocks are made up of what? Silicates. They are a main composition of a earth crust. No? Okay, so avnella nodidre almost nearly half of the mass of the earth crust composed of what? Oxygen, nearly 46.6%. So next one will be, okay, next one will be silicon, around 27.7% by mass of the earth crust. Aluminium is the third element with the abundance of 8.1%. Rest will be iron, calcium, sodium, potassium, magnesium, and so on. Okay, avnella nodidre oxygen is the most abundant element in the earth crust. When you are talking about the atmospheric air composition, oxygen is the second most abundant gas in the atmospheric air. So ಇಲ್ಲಿ earth crust mass ಬಗ್ಗೆ ಹೇಳಿದೆ, ಆದರೆ ಇಲ್ಲಿ in the atmosphere, ವಾತಾವರಣದಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಗ್ಯಾಸ್ ಎಷ್ಟು ಪರ್ಸೆಂಟೇಜ್ ಇದೆ? So it is present around 20.95, or we call it as a 21%. So first abundant gas in the earth atmosphere is what? Nitrogen. 78% of atmospheric air composed of nitrogen. Oxygen second place alide. How much? Around 21%. So rest gases will be what, to an extent of only 1%. Andre carbon monoxide, carbon dioxide, noble gases, oxides of nitrogen, so they are present to an extent of only 1%. And oxygen 21%, nitrogen 78%. Okay, so this is about occurrence of elements, the abundance of elements in the earth crust as well as in a atmosphere. Okay, yes. Next one, sulfur. Second element is the sulfur that forms only 0.03 to 0.1% of the earth crust compared with that of oxygen. Oxygen 46.6%, whereas sulfur 0.03 to 0.1% of the mass of the earth crust composed of sulfur in the form of the combined form of sulfates, gypsum, CaSO 4.2H2O, Epsom salt is a magnesium sulfate 0.7H2O, or even barium sulfate, we call it as a baryt. Okay, so these are the existence of a sulfur in the combined state, mainly in a sulfate form. Calcium sulfate, magnesium sulfate, barium sulfate. Adin bitre, sulfur, it's present in the form of a sulfide form. Sulfur is present in sulfide formally. Lead sulfide, PBS. PBS is lead sulfide. It's commonly called galena. ZNS, zinc sulfide, commonly called zinc blend. And CuFeS2, it's a copper pyrites. These are the sulfide ores of sulfur. Even sulfur is present in proteins, it's present in garlic, it's present in onion, mustard, hair, and even wools also contain what? Sulfur. And the pungent smelling smell of a rotten eggs is of a sulfide form. Okay, andre egg also contain sulfur. Okay, these all constitute how much? Only 0.03 to 0.1%. Yes. Then other elements of group number 16, they are selenium, tellurium are found as selenites and tellurides, metal selenites and metal tellurides. Okay, they are of what? Sulfide ores only, selenite, telluride ores. And the polonium is a radioactive element. Polonium occurs in nature as a decay product of thorium and uranium minerals. Polonium is a radioactive element. And the last one, livermorium, with a symbol of Lv. So it's a recently discovered element. We don't have much data about the livermorium element. Clear? Okay. So fine. This is about the occurrence of chalcogen oxygen family. Fine? Okay. Let us move to the next concept. Trends of periodic, physical and chemical properties of the group number 16. First, let us look at the electronic configuration of group number 16 elements. Oxygen with atomic number 8, its electronic configuration is 1s2, 2s2, 2p4, or in short, we write it as helium 2s2, 2p4. Sulfur with atomic number of 16 contains 16 electrons which are distributed into different orbitals like this: 1s2, 2s2, 2p6, 3s2, 3p4. Selenium, argon 3d10, 4s2, 4p4. Look at the outermost shell. Oxygen 2s2, 2p4, sulfur 3s2, 3p4, selenium 4s2, 4p4, tellurium 5s2, 5p4. Hagadre, what's the general outer electronic configuration? 2s2, 2p4, 3s2, 3p4, 4s2, 4p4. In general, we write it as ns2, np4 is the general outer electronic configuration of group number 16 elements. And how many electrons are there in a valence shell? 4 plus 2. Total 6 electrons are present in a outermost shell, valence shell, and has a ns2 np4 general outer electronic configuration. It's a first periodic property, electronic configuration. Second one, atomic radii or ionic radii. Okay, so when you move down of the group. You take any group. So here in particular, group number 16, from oxygen to sulfur to selenium up to livermorium. What happens to the atomic size? What happens to the atomic radius? So we know that it increases due to the increase of what? Due to the increase of number of shells. When you move from oxygen to sulfur to selenium, the atomic number increases. The number of electrons are increases. The electrons are being added to the new and new shells. That means when you move down, the number of shells increases. Then definitely the atomic radius or even ionic radius increases from top to bottom in the group. Okay, these are the values of atomic and ionic radius that increases down the group. And this concept, no, we discussed in a PUC first year in detail why it decreases and all. So here only we are studying how it varies. It varies, it increases down the group. The third periodic property is ionization enthalpy. So you know that ionization enthalpy is what? It's the amount of energy required to remove outermost electron from an isolated gaseous neutral atom in its ground state. Okay, so this we discussed in a last year in a PUC first year. We have studied this concept. Now we'll see how it varies in the chalcogen, how it varies in oxygen family in group number 16. You know, what's the general trend? Ionization enthalpy decreases down the group. The reason is very simple, because down the group there's an increase in atomic radius. There's an increase in size of the element. As the atomic radius increases, size increases, the removal of outermost electron becomes more and more easier. Therefore, they require less and less energy when you go down. Hence, ionization enthalpy decreases down the group. But you know how it varies along the period? Along the period, it increases. This concept we studied in the previous year. How the along the period increases, down the group decreases. Okay. So when the along the period increases means 13 group kinta 14 group will be having higher ionization enthalpy compared to 14, 15 having higher enthalpy compared to 15, 16 having higher enthalpy. No, but look at this exceptional case. However, the elements of this group number 16, have lower ionization values compared to group number 15 in the corresponding period. So general trend ಏನು 13 ಕಿಂತ 14 ಜಾಸ್ತಿ ಎಂಥಾಲ್ಪಿ ಇರಬೇಕು, 14 ದಿಂದ 15 ಜಾಸ್ತಿ ಇರಬೇಕು, 15 ದಿಂದ 16 ಜಾಸ್ತಿ ಇರಬೇಕು. But 16 have lower ionization enthalpy than group number 15. It's exceptional case in that trend. ಯಾಕೆ 15 ಜಾಸ್ತಿ ಇದೆ, 16 ಕಡಿಮೆ ಇದೆ? The reason is group number 15 element. This concept we discussed in a previous classes. Group number 15 elements have extra stable half-filled p orbital electronic configuration. You know, group number 15 electronic configuration is ns2np3. So p can accommodate maximum of 6. It contains exactly half. It contains 3. You have studied. Half-filled and completely filled atomic radius, atomic orbitals are said to be more stable. So group number 15 elements are more stable compared to 16. When they are more stable, removal of electron becomes difficult. They require higher energy. Here the removal of electron is easy, require lower energy. Hence they have lower ionization enthalpy. Group number 16 have higher ionization enthalpy. Clear? Okay. Well, we'll move to the fourth periodic property. It's electron gain enthalpy. Okay, do you remember the definition of this property? It's a change in energy. Electron gain enthalpy is a change in enthalpy occurs when an electron is added to the isolated gaseous neutral atom in its ground state. Okay, So during whenever an electron is added to the neutral atom, whatever the change in enthalpy take place, that enthalpy is called electron gain enthalpy. And the general trend, so this concept also we have studied last year. The general trend is that when you move down, electron gain enthalpy decreases, or we call it as a, it becomes less negative, less signed less negative down the group. Less signed less negative means what? When you move down, less signed less energy is released. Less signed less energy is released means what? The electron gain enthalpy decreases when you move down. But this concept holds good from sulfur onwards. Sulfur nantara. Sulfur to selenium to tellurium to polonium. Electron gain enthalpy decreases or becomes less negative. But from oxygen to sulfur, okay, the picture is different here. However, we have an exceptional case. Oxygen has less electron affinity than sulfur. Electron affinity andru ಒಂದೇ, electron gain enthalpy nu andru ಒಂದೇ. Okay, both are one and the same. Oxygen has less electron gain enthalpy. So when you move down, decreases means oxygen must have a more, sulfur must have a less value. But exceptional case ಏನಿದೆ, oxygen has a less, sulfur has more. Why? This is because the size of oxygen is very small. Oxygen is a very small atom. So where the valence electrons are placed very closely, when the atom is small, the orbitals are small, the electrons are closely placed in the smaller 2p orbitals in case of oxygen. And apart from this, addition to this, if we add an electron, electron gain enthalpy andre no, it's we are adding an electron, no. To add an electron, to add an external electron will result in an increase in electron-electron repulsion. First of all, the oxygen atom is small. There's a smaller 2p orbitals. Electrons are placed very close to one another. If you add an electron, there will be electron-electron repulsion. Negatively charged electron-electron repulsion will take place. Therefore, the addition of electron becomes a bit difficult. It's not easy compared to rest of the elements. So when it is difficult, oxygen experiences much attraction. Therefore, oxygen has a lower electron gain enthalpy. Okay, you may be asked this concept for 1 mark in the examination. So ನಿಮ್ಮ ಆನ್ಸರ್ ಏನಿರಬೇಕು, this box and this box. These are the reason for this. Oxygen atom is small, there's a what, electrons are closely placed, and there will be electron repulsion. Hence the addition of electron becomes a bit difficult, what releases less energy. Clear? Okay. So look here. What's the conclusion? Oxygen atom has less negative electron gain enthalpy than sulfur. Clear? Okay. The last periodic property, electro negativity. It's a power, capacity, tendency of an atom in a molecule to attract shared pair of electron towards itself. That property is called, that capacity, that power is called electronegativity. You know, fluorine is the element with the highest electronegativity. Next to fluorine, second highest value is having oxygen. Oxygen is the second highest electronegativity value among all the elements. And you know, down the group, electronegativity decreases as the atomic number increases, and atomic size increases, electronegativity decreases. These are few periodic properties of chalcogens, oxygen family: electronic configuration, atomic radius, ionization enthalpy, electron gain enthalpy, and electronegativity. We'll see very few physical properties, ಭೌತಿಕ ಗುಣಲಕ್ಷಣಗಳು. The first two members, oxygen and sulfur, are non-metallic. The next two members, selenium, tellurium, are metalloids in nature, and the polonium is a radioactive, it's a metal. And the polonium is a radioactive with a short, where it's a very short-lived half-life period of 13.8 days. All these elements exhibit allotropy, ಬಹುರೂಪತೆಗಳು. Okay, they exhibit allotropy. And when you go down, the melting and boiling point increases. Definitely, because there will be increase in atomic number down the group. Atomic number increase ಆಗ್ತದೆ, atomic mass increase ಆಗ್ತದೆ. There will be increase in melting and boiling point. Okay, the general trend is followed by this group also. But there is one important property. There is a large difference between melting and boiling points of oxygen and sulfur. Oxygen has less MP, BP. Sulfur has more melting point and boiling point. But the difference is very much high. Okay, why there is a large difference? The reason is atomicity. Oxygen present in a diatomic state. Oxygen is present in O2 form, diatomic state, whereas sulfur exists in a polyatomic state. Sulfur, a molecule of sulfur contain 8 sulfur atoms. ಒಂದು molecule ಅಂದ್ರೆ S8. One molecule of oxygen ಅಂದ್ರೆ O2. Sulfur ಅದೇನು S8. Sulfur is polyatomic in nature. Oxygen is diatomic in nature. Because of a difference in atomicity, there is a large difference in melting and boiling point between oxygen and sulfur. Okay, these are few physical properties of group number 16. In the next class we will discuss some of the chemical properties of group number 16. Along with that, we'll study oxidation states, we'll study anomalous behavior, and we will study some of the chemical properties of group number 16. Okay, so with this I'll conclude my today's class. Share this video to your friends and subscribe to my YouTube channel. Thank you very much.